Okay, I have two special questions for you to do. So this would be, I think today we called them example 1 and 2, so this would be example 3. And it was the one I was hoping to get to today. So now that I've done question 9 with you, this one should be all right. Okay, so it's an incline. There's a box on the incline, M2. There's a box hanging up here, M3. There's a box hanging down here, M1. M1 is 20 kilograms. M2 is 40 kilograms. The coefficient of static friction for M2 is 0.4. And the question is, what is the range of values for M3 that would hold this system in place? Range of values for M3. Okay? So that's one I'd like you to do. And the second one I would like you to do, you're going to love this one. Yeah. It's going to look similar to what we just had up there. So a box here, a pulley, a box here, another pulley, a box here. We'll call this one M1, call this one M2, call this one M3. M1 will be 10 kilograms. M2 will be 20 kilograms. M3 is 30 kilograms. Coefficient of friction is 0.3. And you want it to accelerate up the incline at a rate of 2.5 meters per second squared. But you're worried that it isn't going to. So you decide you're going to give it a push. So the question is, with what force are you going to push it? Now you're going to push on M2 because it's the one on the incline. And of course, you're going to push this way. With what force must you push directly into the incline, pretending like you haven't taken physics, so that this system will accelerate up the incline at a rate of 2.5 meters per second squared? Isn't that a great question? Okay, so try these two. You might have noticed in the last video I didn't do 9b, just because the video ended. In 9b, you just add 5 kilograms to the bigger mass for M3. Obviously, if you add it to the smaller mass, it's not going to move. So add it to the bigger mass and solve for the acceleration. So if you're not able to get the answer that's on the sheet, I can do that in class with you the next day. But in the meantime, try these two. And then after you finish these two, work on your assignment. Because really, with the exception of another couple of really good ones I have for you to do, we're done the unit and we'll now move into something else. So we're almost ready for a test. So work on those assignments. Okay? Very good.